For 3 decades, one hypothetical matchup has dominated playground arguments and online forums: Goku versus Superman. If you try to research an answer, you run into a wall. Fans constantly argue by pulling specific feats out of decades of comic book pages and manga panels. The flaw in this approach is that different writers possess varying understandings of physics. One author has a character struggling to lift a building, while another has them pulling planets out of orbit. The lore is too inconsistent to provide a baseline. To find a definitive answer, we have to discard narrative fiction and evaluate both characters as overlapping biological and thermodynamic systems. By treating them as physical mechanisms, we can pinpoint the exact mathematical threshold where Kryptonian biology fails against Saiyan kinematics. Applying strict physics strips the emotion out of the debate. It provides a conclusion based entirely on mass, energy, and time. Applying rigorous physical science to these theoretical boundaries reveals exactly how these two systems interact. Superman's physiological system is essentially a high-capacity biological battery. His power input is the continuous integration of external solar flux. In sun-dipped states, this absorption allows him to output energy equivalent to a dwarf galaxy, approximately 10 to the 59th joules. Under a yellow sun, Superman functions as a biological perpetual motion machine. As long as the environmental solar conditions hold, his stamina is mathematically infinite. Without direct sunlight, he enters closed-system isolation. His power becomes a slowly draining capacitor, rather than a multiplying spike. Because his energy is drawn out over an extended curve, his primary advantage is long-term sustainability. Superman's physics mandate a strategy of attrition. He is built to outlast. Goku's power relies on an internal, finite metabolic reservoir of key energy. His scaling follows a discrete step function. Every transformation serves as a multiplier that increases his physical output in sudden, vertical spikes. These multipliers move his output from planetary levels to universal scaling, easily matching that galactic level 10 to the 59th joule threshold. At the peak of this scaling, Ultra Instinct, Goku moves beyond standard kinematics into quantum probability. By decoupling his reaction time from his synapses, he occupies all possible defensive vectors simultaneously, a state of quantum non-locality. He can also utilize Hakai, an offensive technique that targets the structural integrity of atoms, bypassing an opponent's cellular durability. However, these extreme power spikes are subject to the second law of thermodynamics. They result in massive, unsustainable metabolic depletion. Goku is a thermodynamic glass cannon. His peak performance operates on a critically strict time limit. What happens when these two absolute max power systems collide head-on? Imagine Superman executing an infinite mass punch against Goku's god-tier Kamehameha. This impact concentrates that previously calculated 10 to the 59th joules of energy into a single microscopic point. This resulting mass energy density instantly creates a massive Schwarzschild radius. The event horizon expands to roughly 0.17 light-years across, swallowing the entire solar system. The resulting black hole would take over 3.4 times 10 to the 102nd years to evaporate via Hawking radiation. Max power collisions between these two systems result in universal-scale mutual destruction. Since one system is a static capacitor and the other is a state of quantum probability, the victor is dictated by the temporal boundary of the fight. This quadrant charts battle duration against combat intensity to map the final answer. Scenario A is the long war. Superman's win condition scales with time. Scenario B is the short blitz. Goku's win condition spikes with intensity. If time approaches infinity, Superman wins. Continuous energy harvesting will always outlast a finite metabolic reservoir. If intensity hits infinity instantly, Goku wins. Superman cannot physically land a strike on a target that has achieved quantum non-locality and decoupled its reaction time from standard neural synapses. The math solves the debate. Specify the duration of the fight and apply the thermodynamics.